Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will continue with the slash protective textiles. So, let us try to understand the mechanism of slash protection, how this slash protection mechanism are different from cart or stab type threads. So, core principle is that here a knife with its tip and sharp edge penetrates the fabric using its tip, then slice through the fiber with the cutting edge. That is very important. Now, if you see a knife, this is a knife, here is this is a tip, the tip is used for the stab, okay, and it goes perpendicular, but here the first tip comes into picture, okay, and which creates a point, punch the fabric, then the sharp edge, this is the sharp edge which actually slice the fabric, slice through the fabric. The fundamental mechanism of a knife cut is compressive fracture. That means, the material like textile, the fiber material will get fracture by the compression, and this compressive pressure is generated due to the very small single edge area. So, this compressive fracture takes place and a slash attack starts at the stab. Any slash attack start with the stab at a point of contact, then it continues behave like a cut with slicing motion. So, first it start with stab like at a point, then it will behave like a cut with a slicing motion. So, it is a mixture of first stab then cut. Now, try to see with this animation, this is the pointed tip, and here is the sharp edge. This is the pointed tip and here is the sharp edge, pointed tip and this is the sharp edge is there. Then what will happen, and this is the first point of first contact, and here it penetrates the fabric with the help of this pointed tip, and then it will slash through the fabric. That means, penetration will be there at the pointed nip, and then this is slice through the fabric, that is the slice through the fabric, that is slashing action. So, the role of the blade is the effectiveness of the blade is due to its function as both wedge and lever. So, both the functions wedge and lever functions will be there here, and the sharpness of the blade and the angle between the edge, that edge influence in the to the depth of the cut. The sharpness can be defined as the attribute that allows the cutting operation to be performed with minimum effort, that is the sharpness, which means that contact area is low, to achieve the maximum sharpness the edge angle must be low and the tip radius must be small. Like this is the edge angle, okay, theta 1, and this is the edge angle theta 2. So, theta 2 is less than theta 1. So, that means this one 2 will be more sharp, and at the same time the tip radius. So, if the tip radius is high, another case tip radius is low, that will also be with a lower radius, it will be sharper. So, the sharpness mainly depends on the two factors. One is the edge angle and the tip radius. So, the initial incision is pure function of sharpness. So, sharpness must be there for creating the slash. The two phases of the knife impact, phase 1 is the initial contact, where the knife's force cause the target material to move away. The knife starts to open up the material, the material begins to blunt the knife point, so that is the first initial contact. After initial contact, the second phase is that run through, where this occurs once the knife has completely pierced the material, and the knife opens up the material and penetrates through the hole it already made. So, that it penetrates, that is a run through. So, two phase processes are there. So, the main goal of the slash resistant fabric is that the primary goal is that to absorb energy during the first phase. What is the first phase? Initial contact. So, whatever the things happen here in initial contact. Okay. So, that it at the initial contact it should absorb the maximum energy. So, for the first phase of knife impact and preventing the second phase from occurring. So, slash resistant, that it should not penetrate. The clothing's main function is to prevent the knife from the penetrating, so that second phase does not occur. The material must disperse the kinetic energy from the penetrating object over a large area to prevent localized damage. That type of energy dissipation should be there. And third one is that film lamination and abrasive coating can also be used to improve the slash resistance characteristics. So, while designing the clothing for or textile material for slash resistance, we have to keep all these things in mind. So, first is that here energy absorption we have talked. So, absorb the energy, for that we need high performance fiber. So, the materials used for slash resistance is that first is high performance fiber. So, most common fibers for armor production is that Kevlar, Spectra, Dyneema, Xylon. So, these are the fibers which are used for slash resistance textile. These fibers all have excellent strength to weight ratio, okay, very high tenacity and also very high modulus. However, they differ in other properties like heat resistance, moisture regain. So, these fibers they have their different heat resistance, moisture regain or maybe melting point, but all of these fibers have very high strength and high modulus. Then we have to develop different types of yarns for slash resistance. So, the yarn which has to be developed, the yarn should be able to absorb the force of a knife and that will resist shearing at the point of contact. So, that type of yarn should be there and which will help blunt the edge knife. So, knife edge has to be blunted. So, staple fiber yarns offer different types of advantages. So, that they are preferred over continuous filament because they can dissipate force over large areas due to their compressible structure. So, here in for slab resistance staple fiber yarns are often used, and staple fiber yarns they have the main drawback is that their strength properties due to the twist application, the fibers share of the fiber load on the total strength characteristics are reduced as compared to the continuous filament. So, composite yarn is the solution in which multiple materials are used, like core sheath structure, the continuous filament along with the staple fibers, and multiple fibers are used, different types of fibers. So, multiple materials are used for high performance application, okay, for their multifunctional use applications. The composite yarns, as I have mentioned, that it is a core yarn and a covering strand, that type of composite yarns are used. The core filaments contributes to the mechanical performance. So, due to its high strength, they offer high strength. So, they resist the any slashing or the energy absorption, they act great performance there, and cover yarns can provide additional properties like skin friendly surface, it will be soft, insulating, good handle. So, that is this multiple structure composite structure yarn is preferred. Advanced composite yarns can include components such as glass fibers or ultra high molecular weight polyethylene or pararamide. So, different types of high performance fibers are used as core, and also in the sheath different types of staple yarns, staple fibers are used. Now, the fabrics are different structures, fabric structures are used for slash resistance. These fabric structures are mainly woven structures, like tightly woven structure, particularly plain weave or tightly woven twill or satin structures are also used. Woven, non-woven composite structures or laminates are used for slash resistance. Knitted fabric, both warp and weft knitted fabrics. Majority of cut resistant products are made of with the plain woven or its derivatives. Knitted fabrics, especially weft knitted one, offer advantage in cost and versatility. So, weft knitted fabrics are the production rates are very high, and they are more versatile, but have low initial modulus, which is the drawback. So, due to the stretchability, sometimes they are not preferred. So, majority application is that in the plain weave structure, also twill satins are used in slash resistant textiles. Apart from the different types of fabrics, the laminates are also used. So, laminated fabrics, like combining two or more materials to maximize the useful properties, like Spectra Gold Flex is a product, it is a unidirectional laminate of 4 layers of aramid fiber, provide lightweight and high trauma protection. Spectra Gold Flex is a commercial product. Dyneema UD, it is also unidirectional 2 layer laminates of ultra high molecular weight polyethylene filament. It is known for being one of the strongest and lightest ballistic protective material. Boron SRM, that is, it uses silicon carbide particles to dull the blade, okay, and high impact resistant fabric which catches the weapon. So, different types of laminates are used commercially. So, impregnated materials are also used, like impregnated with aramid fabric, impregnated with shear thickening fluid to enhance the ballistic protection that we have already discussed. Here in shear thickening, in slash also we can use this impregnated material. So, however, this impregnated aramid provide better ballistic and stab resistance. They have shown very little improvement in cut resistance. The cut resistance are very slow, but one can expect that improved performance for slash resistance testing, because slash is relatively faster. So, the testing, if we see the slash resistant testing, there is no ISO, ASTM, BAS, BIS standards for slash resistance testing. That is the problem which I have already mentioned. The only testing method that was published in 2008 by Home Office Scientific Development Branch for UK Police in the United States, United Kingdom. So, in UK, for the UK Police, that there is one standard available, and this was further modified at Home Office slash resistant material standard in 2018. The Home Office Center for Applied Science and Technology and law enforcement and from the UK updates their need and method to make the slash resistant tester. So, there are different modification in this standard, but no international standards are available. So, rationale of this the test is that the different levels of protection of the test were selected according to the level of threat to the different region of the body. So, SR1 was the level, that is slash resistant 1 level. This represent the level to the lower risk area of human body, which may not be life threatening, like hand, arm, fingers. For that, the low risk areas, lower level SR1 and SR2 offers high protection, high risk area. So, SR2 level, this actually it is a high risk area of the human body, which can be life threatening, like throat, stomach, chest. So, two levels of the protective garments are available, and based on the this getting the idea from the home office test, we have developed our internal tester, that is a slash resistant tester here. So, this is the frame for the tester. And this is sabot, which will actually this here this will have free fall on the specimen, this sabot with certain load, and here is one knife projected. We can see, and the material is placed at certain angle. This is the sabot, here is the blade, projected blade is there. Now, the fabric specimen is kept and the copper bar is there for identifying the penetration, fabric holder which holds the grips the fabric, and a base of the fabric holder which is the support, main support. Now, here the sabot moving upward and then downward. So, this will be lifted upward and there will be free fall, and during this free fall this knife will slash the fabric and the cut through distance and energy will be measured. There is a free fall, you can see, and this is the process of slashing. Now, this is the spring inside the sabot which will actually during the slashing it will give the slashing force, slashing pressure. So, that will ensure that there is no impact heat. So, fabric holder is inclined at 2 degree, there is a 2 degree inclination. So, effectively this is 88 degree. The sabot weight is 2 kilogram and there is a standard spring behind the blade to absorb the initial shock during the slash. So, sabot that this there will be a initial shock when there is an impact. So, to absorb that initial shock, the spring is there, the standard spring is there, and sabot starts the fabric edge distance is the 185 centimeter. So, at the start of the sabot starts here and the fabric edge distance, this distance is 185 centimeter, it is calculated. That means, after 185 centimeter fall, that the knife will start touching the fabric edge. So, the blade and spring standards. So, blade model which was used Stanley knife blade, that is model 1992. the sharpness of the blade should be as per the ISO standard using 25 millimeter strike length. Initial cutting perforation of each blade should be 75 to 85 millimeter. Before test, the quality of the blade should be checked and cleaned with alcohol based wipes similar to cut resistant testing. During cleaning and observing, care should be taken to keep the tip of the blade undamaged, because that is the point where this is used for slashing. The blade should be used at once like the cut resistant testing, otherwise there will be blunting effect. This is the blade, standard blade is used with the standard specification. The dimensions are blade length is 2.4 inch and blade thickness is 0.024 inch, that is the thickness of the blade. And the Stanley model, specific model of blade is used, and spring standard, the spring specifications are spring type, the type is the round wear compression, design to BS 1726 1987, tolerance as per the BS standard, material as per the BS standard, patented carbon steel, and N type closed and ground. The very specific spring was used here, wear diameter 1.83 millimeter, that is the wear diameter, and outside diameter it is 18.29 millimeter, that is the outside diameter, and spring rate, that is spring constant 8.41 Newton per millimeter, and free length 12.23 millimeter. So, this is the detailed spring specification. Now, fabric support table, and this instrument is patented with the different new parameters have been added. This is the automated version, 2 load cell at the back of the copper plate, identical load cell, and foam backing to support the fabric. A circuit is being used to detect the slash after the cutting the fabric. The blade and the copper plate are two parts of the circuit. After the specimen is slashed, the blade and copper plates come into contact. From here the perforation duration and slash load are calculated through the sensor. So, these are the different stages of data collection. Now, the sample preparation. So, conditioning is there, first samples are conditioned for a minimum of 12 hours before the test at the temperature 20 plus minus 3 degree Celsius, at relative humidity 55 plus minus 25, this is as per the standard. The sample should be laid flat and piling and stacking of the samples should not be more than 4 samples. So that to avoid any compression. Now, force table calculation. So, this what is the calibration table will be there, force table calibration before any test. The test is that force table calibration should be performed. Now, the two types of loads are there. So, 6 and 12 kg plus minus 1 kg. So, applied to contact plate, horizontally place on the force table, there is a force table that we are calibrating with the two loads. Place mass at the center of the force table. After 5 seconds, remove the mass and calculate the voltage drop. So, from the voltage drop and with the known mass, so we can calibrate the force table, and then we repeat the total process 3 times. So, force table sensitivity is that mean voltage drop divided by mass applied, whether 6 or 12 kg multiplied by 9.81. So, this is the force table sensitivity. Now, slash energy calculation, here is the slashing. Now, sabot weight is say m kg and height is h and acceleration due to gravity it is g. From there we can calculate the sabot energy, required sabot energy, and if we know the required sabot energy and if we have the mass, known mass for a fixed mass, we can calculate the height required to apply certain energy. So, in any standard the energy will be fixed. So, slash energy is mgh joule, and here at this point where height we have kept is say 1.85 meter and mass is 2 kg and g is 9.81. So, from there we can calculate the sabot energy of 36 joule. So, 36 joule is our slash energy. Sample requirements for testing. So, for testing we need large number of samples. So, in wave direction we need 3 specimen, 3 sample, then warp direction again 3 samples, then at 30 degree from either warp or wave direction 3 samples again, and at 45 degree 3 samples. So, we have total 12 samples per specimen. So, for testing one specimen we need to take the 12 specimen for one sample. So, we carry out the 12 slash resistant testing, then take the mean of this data. The test procedure. So, the protection level we can see there are two different types of protection level, SR1 and SR2. Now, these are the protection level here. SR1 here its energy level is 36 plus minus 2 joule and minimum perforation force is 30 Newton and minimum mean perforation force is 14 Newton and the maximum perforation duration is 1.7 millisecond, that it is a perforation duration at less than 80 Newton, less than equal to 80 Newton load. And SR2 the energy requirement is same 36 joule, but minimum perforation force is 60 Newton and minimum mean perforation force 80 Newton, and here the maximum perforation duration is 1.1 millisecond with less than 160 Newton load. Now, here we see the 36 joule is the requirement. So, in our case, so 36 is the joule requirement, our 2 kg was the load, and from there through back calculation we have actually reached up to this 1.85 meter. So, this we have reached. If we know the 36, we have to reach the 36 standard the energy required, and if we have 2 kg the load of the sabot, weight of the sabot. So, from there 1.85 centimeter, 1.85 meter the height was kept. Now, try to see the, let us see the actual running of the instrument. Now, the fabric is being placed in the fabric holder. So, any this wrinkles and folds are being removed, and the fabrics are the bottom portion of the lower portion is kept free to simulate the exact running condition, and the angle of fabric holder is kept 2° inclination. This is a sabot with the blade, and then this is the free fall, and the total instrument is computer controlled, and we get the total the penetration force with the time, that time versus force, this plot we have got, and then we can analyze the penetration force. Now, the test procedure. So, first we have to fix the fair strike. The strike energy should be within the range of the protection level mentioned in the previous table. The strike energy we have to keep within the say 36 joule. The strike should be 50 millimeter from either side of the edge. That should be away from this 50 millimeter away from the fabric edge. Any strike that does not meet any of the clauses are of fair strike will be assumed unfair and it will be rejected, and the repeat trial will be taken, that result will be rejected. And first we have to perform the test strike. Before starting the test, the operator should drop the sabot to the force table without the sample to ensure velocity measurement, where the velocity is measured correctly, electrical contact circuit. So, whether it is working properly or not, data processing system, whether the data processing system is working properly or not. Now, the test strike. 3 strike, as we have discussed, it is a weft direction which is horizontal. So, weft horizontal, it is H1, H1, H2, H3, 3 horizontal, then 3 weft vertical, V1, V2, V3, then 3 weft 30 degree. So, 31, 32, 33 and 3 45 degree of the horizontal, 45-1, 45-2, 45-3. So, total 12 tests were performed on a particular specimen. This is as per the direction which has already been mentioned. The sabot should be raised to the predetermined height and dropped under the influence of the gravity. This predetermined height depends on the weight of the sabot. So, in our study we have used the 2 kg sabot. So, the data analysis, the force time data and the electrical contact data are recorded. So, here in x axis it is a time in millisecond and in y axis it is a load. This is the peak force and laceration time. The force is 25.9 kg, that is 254 Newton. So, laceration time is 33 millisecond, 33 millisecond. average of such 12 samples will provide the final slash resistance level. Now, the perforation assessment criteria according to the standard, some short duration perforation can occur, that should be neglected. So, the slash, the perforation should be the long duration, force time data should be used to identify the significant perforation of the test sample. Perforation should be considered if the time is more than 0.2 millisecond, then perforation will be considered, otherwise it will be neglected because it will be short duration perforation. If the peak force is greater than 120 Newton, then it will be considered as the 120 Newton. And the entire data should be analyzed to identify the minimum force at which the sample was perforated at the single test. So, minimum force. So, at an there are 12 data. So, minimum force will be considered. So, that is recorded, and the mean force at which all the samples were perforated, that will be recorded. Sample where the perforation duration exceeds the limit of the standard and the maximum force recorded during the laceration, that will be recorded. So, all this data will be used for assessing the this slash performance of textiles. Now, we will discuss the studies which was carried out for assessing the slash resistance. Here we have developed different fabrics with a 6-end satin was used. The same fabrics which was used in cut resistant testing, that same fabrics are used here, that is stainless steel core and glass core with different GSM. So, 150 aerial density, 150 grams per square meter, 200 GSM and 250 GSM. 3 GSM we have used, and the thread densities are manipulated to have particular aerial density, because these yarns their linear densities are different. This FY1, in that yarn the linear density is finer because of the core which was used. It is a low micron, lower micron, I think it is 30 micron stainless steel, whereas FY3 where it is 50 micron stainless steel. So, for that, to keep same aerial density, the ends and peak density for FY1 is higher than FY3. So, this same logic is maintained in for other areal densities. And Fy 7 to Fy 12 are basically made of glass core. Now, different fabric structures were developed. Here 250 GSM, 250 GSM fabrics are much more compact than 150 GSM. So, different fabrics were developed. So, 250 areal density fabrics were much denser. Now, slash test data. So, this is the typical plot of the slash test, where 18.2 centimeter was the slash. So, that this all this data analysis. So, we will continue with this slash test data analysis in the next session. So, till then, thank you.